Hey, can they see me? Okay, awesome. I am, welcome folks. This is Brooke Drum with Printrbot.com, doing our live broadcast every Thursday at 4:30 PST. Live on Facebook, unlive elsewhere. So, I got a lot of stuff to share with you today, and I just want to make a couple of disclaimers. First off, you're getting the unfiltered Brooke today, and what that means is I have not shaved for no particular reason, except that I'm a little bit lazy sometimes. So, not looking my best, but that's okay. We got a lot done. All right, so I tweeted out yesterday, the thing I'm most excited about today is, I have some Peak. Peak is here. It's the beige looking stuff. You'll perhaps recognize Peak from the kind of beige or tan or whatever that is color on our traditional hot ends. If you got one of the old Ubis 13s that was all metal, we retired that to make some modifications to it, and it's taken a very long time, but we got it right. I'm going to tell you about this high temp hot end, which is here, and this is a high flow, and it's just slightly longer, I believe 0.2 inches longer, and it has some differences. I guess I might as well point them out. There's a Delrin cap on top that's interchangeable. The nice part about that is it can be modified for other mounts, but also is an insulator. Same aluminum. I believe that's exactly the same. Yeah, it looks like, well, no, it's not. It's different. It's different because that cap screws on. So there's a cooling zone that's quite a bit longer. Or, yeah, the cold end is longer. And then I actually have to pull this down a little bit different. Look at that. It's got the, like the high flow, has 2x the height of our regular 13S heater. And there's some very special mojo happening in here that I would talk about if I knew what the heck it was, but Carl's a very secretive man. So this is actually, our high flow is a 12 volt, and there's a little secret code under here. This is a 45 watt special model that we're testing using with the prosthetic printer, 45 watt heater on the high flow. By the way, it has a Teflon tube and a Peak insulator in between the cold and hot zones. But it is a longer melt zone. This is a similarly long melt zone. And these are both high flow. So the longer hot ends do, and that annoys some people, but listen, engineering, gravity's the law, thermodynamics is the law. You just can't get around it by making some short little hot end that you're all proud of how short it is. It needs to be correct and perform well. So we like this slim. We don't like the big block like E3D uses. Really easy to put a couple holes in a machine block. This is hard, and it's hard for a reason. The exact lengths are correct. All of the heater is contained within this little aluminum bobbin here, and hand wrap nichrome wire around it very cleverly with all the spacing is perfect and everything. To do not 12 volts, 45 watts, but 24 volts, 90 watts. Now, the other thing that is different about this high temp hot end, and we're going to actually use it to see how it goes. But this high temp hot end has a very special, I'm not going to take it out right now, but has a very special temperature sensor. Now, you'll notice all the hot ends that we've done, and this high temp isn't for sale yet. I believe the high flow, this one, our 13S, how much is the 13S just for normal use like PLA and stuff? Dave's going to look. So that one's about 30 watts, 12 volts. And that's just general purpose. And it can be very, very exact. So we use it in the Simple Pro. Good sale going on Amazon right now. But also, we put a 0.3 tip in there, and it's really good for precise stuff. So the 13S is great. This is the high flow. Intended for higher flow bigger tips to run thicker walls. Spiral vase is great. The prosthetic printer uses the high flow. We have some for sale right now. It's around 33 watts, but this one is a special one that we're testing for 45 watts to do even more material, volumetric flow. So this high flow is 12 volts. So you got to completely do different stuff to make. Oh, and by the way, all of our hot ends up to today, use just a regular thermistor, and it's I think it's a 3%. It might. I don't think it's a 1%er. I don't remember. I should know these things, but it's secured in there with a little set screw, so it's not going to come out. It's not just going to pull out. These are interchangeable. This whole thing you can take apart. Same is true of the 13S, so everything is replaceable. Now, the dimensions on the brass tube, the melt zone, between this double stack and the single stack of the 13S is different length. So, you could convert a 13S over to this high flow. But anyway, just want you to know you can take the whole thing apart. But we don't want you building it because there's some nuance involved in how you build this and tighten things and stuff. So we sell these as all assembled units. So how much is the 13S? So the 13S is $59. The high flow is, I believe it's 80. The high flow is 80, and this high temp is going to be, I'm thinking around $100. So yeah, it's a lot of money for a hot end. But do you have a hot end that you can plug into your ramps or your printer board without any additional electronics because you have this super sexy temperature sensor that performs like a PT1000 and does not require any additional electronics, and it performs like a thermistor, but it is a 1%er. We've had them made at a fabrication shop, factory, I don't know what you want to call it, but Carl had these made to spec. He designed it, made some of his own, and so it's sort of like a thermocouple, but it operates and communicates with the thermistor. Most boards operate on thermistor, which is resistance. So anyway, really, really cool, and this temperature sensor goes way up, and it's a 1%er, so that means it's only going to have a 1% plus or minus. So we put the firmware, we put a different table in the firmware, and we put we took off the limit. Normally we limit our hot ends to 275C. Well, we put the limit on this one just for our testing purposes to 510C. I don't even know what that is in Fahrenheit, but it's a bunch. So this thing is a 1%er temperature sensor that can go up and operate easily up to 500C and above. So pretty special because you can take this, change out your firmware, and use any plastic all the way up to Peak, Ultim. So I've got a couple of, I've got Peak here, like I was showing you, and I've got Ultim, I believe it's 910 and 1010 and Ultim 9085, I believe. I don't even know what those mean. But I printed some things. I should go get those. You know where I was at on the desk out there printing? There's 3 different little cylinders that I want to show you. I took this stuff. This has been sitting around for months in my shop, and it comes vacuum packed with one little thing of desiccant. But let me tell you, with this high temp stuff, this stuff you use between 330 and 3 something. But I was running it at 365. I tried some at 375. I'm trying to figure out where the adhesion is best and what flow rates and all that kind of stuff. So I'm very early into this adventure. But I will tell you that here is, there's a clear one, which is, I believe, the 1010. And there's kind of like an opaque that is the Ultim 9085. Hope I'm getting all those numbers right. So this is the 9085. That was the first one that I posted a picture of. A little cylinder, just a hollow thing on an old, this is an old refurb we had laying around the shop, so I just shoved it on there and loaded our new firmware with the new table, and we removed the limit on the or moved it up. So that was the first one. And then I did this one, which is kind of you can tell it wants to be a different shade. And then I did peak. Now all three of these have really bad layer adhesion, but I noticed when it was coming out, it was real bubbly, and Carl mentioned, because he's been doing a bunch of high temp printing, and he says, you got to bake it. So I didn't bake it long enough, but I did bake it. It's funny because you can just put it in the oven for an hour at like 125 or something. It doesn't even try at all to kind of sag or anything, because it doesn't melt till, up over 300 C. So you just want to dry it out, get it in some dry air for an hour at least. And it should print a little better, but I didn't really leave it in long enough. So I thought we'd just start with me trying to print. And oddly enough, I'm just using a stock old simple. In fact, this one has been dropped, so the Z is a little bit off skew. If it looks a little funny to you, that's why. And I want to show you the hack of how I am powering a 24-volt hot end with a 12-volt everything else. So first off, I don't know, Dave, if you can zoom in here a little bit over in this area. So first off, it's running just a 12-volt printer board. And, I'm leaving it plugged in just like that. But I've pulled the hot end wires. On this one, there's just one black and one red. Normally, that would plug in and power it with 12 volts. But we want to power it with 24 volts. So here's what I did. I took a 24-volt. This is all because Carl knows how to do this stuff, and he showed me how. So I've got plus and a minus lead coming off the 12-volt power supply off this Molex connector. And we send the ground side of the power supply right to the printer board mounting screw. And so that grounds to the frame. And then what you do is you take the hot end plug-in, and instead of plugging it into the board, you plug it into this extension, which polarity matters. So you plug it into this little extension. This is a connector, just like is on the board. I just soldered them on there and put some heat shrink on it. So you take it out of the board and plug it into here, and then you plug this into the board. So what happens here is that FET is actually acting like the switch. So, and the switch on these 3D printers, they actually switch ground. So when it's off, there's no connection to ground, but when it's on, it connects the grounds and allows all the power to get to the hot end from the 24-volt power supply. So when we release these hot ends, we'll sell this little dongle here, so you can, not worry about your fan running at, or, because I didn't want anybody to worry about, I've got a 12-volt fan, I've got a 12-volt sensor, I've got, what's this 24 volts going to do? Well, this will solve the problems, and it'll give all the power to the hot end at 24 volts. So it's kind of neat. With very minimal modifications, this and this, any of our printers, including the Adopt-A-Bot even, which would be hilarious, you do need to put a fan on this. I don't have a fan on this one right now because it was just a stock one, and I don't have a second fan plug-in on this Rev F5. So I'm just going to be printing a very short print. The heat creep isn't going to matter that much for now, but if I did it long enough, it would jam up. So anyway, that's how I wired it. Pretty cool. But you could do that yourself. If you've got a 24-volt power supply, you could use a 24-volt hot and fix it up like I did. So I'm just using a non-heated bed. It's a cold bed. And a little glue stick. I use the purple stuff, disappearing purple. So it doesn't look purple, but it did when I put it down. I've got a thermistor just tucked in behind the insulator, this red sock insulator. And by the way, that's the one thing on here that over time it will break down a little bit. It's not rated for 500 C. But everything else in there is. And I got the thermocouple here to see what, and this won't be accurate temperature for the actual inside of the barrel. It's outside the ceramic potting. But you'll get an idea. I don't want to do any smoke and mirrors. I want to show you that it's really getting up that hot. So make sure we're still connected. Yep. And I'll Z. Okay. Now I'm going to tell it to heat up to 365 C, and it's going to climb very quickly. I mean, we're totally guessing here, but we were thinking it was climbing about 10 degrees Celsius about every second or so. So it's fast. Because it's 90 watts, it's ridiculous. That's 3 times as powerful as the 13S. It's about twice as powerful as the high flow at 12 volts. And this is 24 volts, 90 watts. Or, yeah, 90 watts. So that's heating up. It's already at 200. And I already have this little cylinder loaded, the same one that I was doing, and I'll try peak and just see how she goes. Now, it's not a demo until it breaks, so this will be awesome if you get to see me wrestle with my machine here. But let's see, we'll hit print. It's reporting 282. Doing its tramming sequence. And should heat up. Yeah, it's already at 370. It's funny, it didn't report, I'm using Piranha Face, believe it or not, but it didn't report the temperature while it was doing its homing. But as soon as it got done, it was like, I'm already at temp. It sits there for a few seconds before it wants to print, but I'll squeeze out a little bit. There's usually a little blob. It's pretty seepy. I mean, oozy, you know. When it's just sitting there, because I have a 0.5, I have a 0.5 nozzle on it. I'm checking what nozzle I'm using. Extruders. So I sliced this wrong. No wonder it's under extruding. I told it it's a 0.4 nozzle. Well, it's not a demo until it breaks, but we'll see what it does. All right, now. Print. It says it's at 3. Oh, I moved it up to 375 in that slice. That's why I think I sliced it wrong. I'm going to get rid of that. Can you see it over here, Dave? I hate that little booger on the front of that. This, just doing the first circle around. It looks like it had some Ultim left in there. And now it's starting on the cylinder. And I'm showing 345 on the outside of the heater. So I can already tell it is smoother. It looks a little bit smoother than this. Maybe I'm just optimistic. Yeah, I can tell it had some Ultim left in there. There's like a little bit of peak. Well, I don't know. Maybe it's kind of translucent when it comes out, but it cools to opaque. That's really weird. Yeah, it definitely looks better. This is kind of bubbly. You can see the surface of it is kind of uneven. But the surface on this is really, really smooth. Dude, I love this. You probably can't see this. I'd have to get a close-up of it, but when it comes out, it's like totally clear. I can see through it. But by the time it gets around to the other side, it's already cooled enough to be opaque. Did not know it was going to do that. So we are printing peak. It's pretty crazy. I love it. So what do you need peak for? I have no idea, but I will tell you that with peak and Ultim, this is, you know, the top of the plastic pyramid. And it used to be pretty daunting to get like any 3D hot end or something like that uses a thermocouple, a PT100. It has, you know, it's real finicky. You got to do programming. You have a separate electronics board with a chip that does the interpretation. It's micro voltage, so it's real finicky. And there's tuning involved and stuff. So anyway, I don't think I'm overstating there, but, you know, I'm trying to make it sound hard, you know, and I'm trying to make this sound easy because I plugged it in with this 24 volts and changed the firmware and we're good to go. But anyway, what I will tell you about this stuff is it's the top of the plastic pyramid, which means there's nothing harder than this stuff that's a thermoplastic, and it is, you can autoclave it. So if you've gone to the dentist and peeked into their lab, you know, there's these machines like stainless steel, they look like little microwave ovens, and they sterilize medical equipment with very, very high temperature steam, and it's under pressure. It's like water, steam under pressure. And you can use these for medical devices. So Carl even printed for his dentist, they have this really expensive camera that acts as an X-ray that's reusable. And so there's no film. There's this really expensive thing that you bite down on, and that mouthpiece that you bite down on, it's different sizes for different people, and those themselves are very expensive. So he got a model and printed one of the mouthpieces. So this doctor can print all the mouthpiece. Well, he did it for him, but Carl can print all the mouthpiece sizes he wants, and you can totally autoclave them because they're inside somebody's mouth for medical sterilization. So pretty crazy. Not blessed by the FDA, or what is it? I don't know what the governing bodies of, what medical equipment you're using, but if you had a need to do a device that needs to be sterilized, you can put this stuff in steam or boiling water and it doesn't break down, it doesn't get soft, because 375 C is what it's printing out right now, is very high. It's not going to, boiling water isn't going to even phase it. So anyway, we're trying the peak here, it's almost done, and then I'll put in Ultim and restart the print. So is there any questions on, oh, look at this. I've got one. You guys are there any questions regarding the high temp hot end? I know I explained a bunch about it, so I don't know that there will be.
Yeah, there was one about temperature sensors and that was right about.
Oh, good. Yeah, so you got to use our temperature sensor and our firmware, but we'll publish that table on GitHub. And there's a couple other things in the code. We fiddled with it for a while. We had one Windows computer, Carl's, and one Mac computer, and I'm the dummy in the whole thing, so we spent most of the time like, how do you get this teensy driver loaded? And I just said, screw it, Carl, you do it. But he was showing me in the code, like, it's a couple of files, the configuration.h, and you change the max temp. And then there was some other thing that was a syntax error that he found that he changed. I don't know that that's necessary, but we'll post the hex. And just use a table, a lookup table, different table. So use our sensor. That sensor won't cost much. We'll have to sell replacements. It is, one thing of note is it's inside, this temperature sensor is actually inside a little, looks like a brass, don't quote me on that, but it looks like a brass cylinder. So it's a glass bead, but I'm pretty sure it's a glass bead. But it's inside a metal housing, and I think he pots it in there with something, so it's not going to come out. But the wires on these temperature sensors are very dainty. This is a higher temp sheathing, and then you can replace this. It's like a cartridge, so you can remove the set screw, take it out. And one clever thing he did was, on this same bobbin, if you wanted to use this particular setup but didn't want to go high temp, you have the same size hole on the other side to put the traditional thermistor in. So you can use it with either if you have need. I don't know. He's really big on like, hey, you can use it this way, you can use it this way, you can use it this way. And I always say, hey, dude, I only want to use it one way, okay, because it's confusing. But he did that. I was going to tell you something else about this. Oh, when you're printing high temp, oh, there was some adhesion. Oh, look at that. Terrible adhesion on this. Whee! So obviously it printed, but it's really cold in here. It's I think a little bit colder than our shop, but the adhesion is really bad. It's a very thin wall. Why? Because I had the wrong nozzle size on it, but at least you got to see it work. If we spit out the right amount of plastic, it would be better. But let's see. Let's try to see what Ultim, I believe this is the 1010, looks like. I don't have to do both. Oh, that's my thermocouple. I got to heat it up to pull that peak out. But when you're using this for Ultim or peak, you could switch between these high temp, if I'm not mistaken, because I've been doing it, you can switch between these high temp plastics. But what you would not want to do is, let's print PLA next. PLA is horrible. When you take an extruder, or hot end, I mean, that you've been extruding PLA with, it'll get a thin wall of that PLA, just a residual like sheen of PLA around that barrel, right? So, you know, when you switch out, if you go from nylon to, or PET or something to PLA, you got to push some plastic through to kind of clean out that barrel. You get rid of that residual around the inside of that brass barrel. So imagine that you just printed in PLA, and then you say, I'm going to print in, you know, Ultem 1010. And there it goes. And you put that in. Well, on the way to 365C, imagine what's going to happen to that PLA, that residual PLA. It's going to char like crazy, and it's going to cause you all kinds of problems. So you would not want to do that. So if you're going to print in this high temp stuff, you do not want to do PLA and then switch over to one of the high temps. You have to dedicate this high temp hot end to using it as high temp. And so what I'm getting from my prosthetic guys is they want, you know, they're trying to use these in offices, and they don't want to know how to change out a tip on a hot end because there's a manual and there's, you know, technique involved so you don't screw up your seals inside this. So what they're doing is, if you want a different size nozzle or tip, they're choosing to buy another hot end with a different size tip. So if they're printing, say, nylon, they'll have one tip for 0.6, and then they'll have one for 1 millimeter. Again, just getting rid of that booger. So that's the outer perimeter, and then it'll switch and do the inside. So if you guys have any knowledge on printing with high temp plastics, on maybe I'm just going too fast, maybe it's too cold in here, maybe it's just not enough plastic. It's a very thin wall, so there's very little adhesion on that. Now, PEEK usually is hard to get to stick to anything, but again, I'm using glue stick and blue tape. So maybe a heated bed would help a little bit on the adhesion. Now, I'm running this too high, I can tell already, because you can hear, or it didn't bake out, because I can hear this. What happens is the moisture inside the filament explodes into steam, and you hear it kind of pops through the plastic, kind of like somebody's chomping gum. Will this high temp hot end go on the new Plus Pro? Actually, yes. So I'll show you that. You know what? I'm going to stop because I don't want to have the noise of this. So you can see that we got a high temp hot end. Check the box. Turn the motors off. All right. We have a high temp hot end. It works. It's performing really well. I just don't know high temp plastic very well yet. By the way, this stuff is freaking expensive. I got it from the UK, 165 British pounds for 0.55 pounds. That's, or maybe it's kilo. I don't know. But it's not very much. See, it's right here. You don't get much on a roll, and that's 165 pounds. I don't even know what the conversion is to dollars, but it's like gold. And this is the, you know, the different Ultems there, and then the PEEK here. And I got it from, the PEEK I got from 3dformakers.com. And it actually recommends 355 to 390C, so maybe I wasn't running it high enough. I was at 375, I think, but I could try it higher. This is from 3DX Tech, Ultem 9085. I don't know what the temperature, it was on the box. Yeah, I think it was 330 to 360 something. And this is the same, 3DX Tech, Ultem 1010. That's the more transparent stuff. So there's our story, our dongle, our 24-volt hack, done. Let me unplug that. Where is it? All right, no more noise. So the Plus Pro, so yes. Oh, wow, 195 USD. Woo! Very, very expensive. Now, I know there are some people in the US that sell this stuff, so good luck with that. All right, let's reposition the camera to the Plus Pro. Now, ever the optimistic, let me just move it a little bit. Ever the optimistic CEO, I said, yeah, we're going to print on this today. And right before I walked in, we got it moving. And so it does, I didn't calibrate the Z yet, so I kind of hesitate to just fly off and have it print. But here is the Plus Pro. And this is going to come standard with, you won't have an option. It is for somebody that wants the option to have an enclosed chamber. And if you'll notice, this is the same, it's almost the same case as the prosthetic bot, but it's our black color for the Plus. Plus Pro, it's all business. It has a, I don't know if you can see it. Under here, it has a silicone heat bed that's running AC. So it's an AC heat bed, very, very responsive. We use a SSR, a solid state relay, hooked to the heat bed. And the reason it's a solid state relay is it's AC. My hack that I showed you, if you had a 24 volt silicone pad, you could try to run that. I don't know about what the FET can handle, but it's a pretty powerful FET. If I'm not mistaken, it was either 75 amps or 100 amps on that FET. It's a really nice FET. Both of those, the hot end and the heat bed FET. But I'm using this with an SSR to turn that on and off, so it gives it AC power. And man, does it heat up fast. And I don't know how many watts this is. It says it's 200 watts. 110 volts, 200 watts. And I got this off Amazon, just to be honest. So it was, what's the, Keenovo? Keenovo. And Keenovo is on Amazon.com. If you want to dump the PCB hotbeds, your heat beds that you guys are using, it comes with a thermistor integrated already, and it's pretty nice. So I like it. I think it's like $38 for this one. Maybe it's 50. I don't remember. But the AC ones are a little more expensive. So that just sticks to what was our Plus bed, and it's a similar case to the prosthetic, but I've left the door off and the top off. You know, that customer made decisions based on his needs, and I didn't really want to have to run with that, or the cost up with that big heated bed with the LCD on top. It creates a lot of extra wiring stuff. So I'll actually lay it down. We had to do one hack on the position. Ugh. It's aluminum case. I hear something. There's a screw or a nut or something. So it's really pretty simple. We've got a 12 volt power supply. This is a Meanwell. Very nice 450 watt power supply. This is our, it's not plugged in, so don't get worried. This is our SSR. It's a Photech SSR 40DA. And the DC side comes over to the heat bed, just plugs in. You do have to make sure the polarity is correct or it won't work. So take a multimeter. You know, if you're facing that connector where the screw terminals are, the one on the left is red, so positive, and the one on the right is negative. You run those to the negative and the positive on there, and that acts as a switch saying, turn on the AC. So the AC jumps over straight to one side of the heat bed, and it's switched on the other side. And then you do have to ground it to the chassis, so there's a ground there. And this big aluminum bed on the bottom acts as a heat sink, and it doesn't get hot at all. So it's pretty cool. The light does come on, you won't be able to see it. And then a regular printer board. And we have already tested these with the G2 board. But with the printer board, it's a little older tech. I mean, it's not a 32-bit ARM processor. But it does have some nice features, like you can reconfigure the size really easily. And if you're a Printrbot customer, you'll be very familiar with this board. So we just threw that in there. And it does provide the option of an LCD with a little SD card slot. So we're going to play around with one that mounts out in front, so you'll see it there right in front of the case. And we might even do a metal mount for that, so it could be nice. So you'd have SD card slot, run it off USB, hook it up to Octoprint, lots of room down here for Octoprint, a Raspberry Pi. So it's all linear rail, and it's you know, just belts up here, but it is linear rail.
Can you tip it forward to show?
Sure, yeah, let's do that. That's forward. You want forward? What can I prop that up with? Yeah, that's like a $400 prop there. All right, so the way the belts go are there's one motor here, and I've thought about doing a jack shaft or something, but this is really simple. The belts run all the way around to the other side, so it's like this C formation. And there's actually two belts, and there's two tensioners. There's a tensioner here and a tensioner here. And so the two sides of the belts can be tensioned independently, and you have to do that to kind of dial in the perpendicular. But once it's set, it's locked, and so it will move very easily. So pretty cool. And then this is just a regular belt loop with the motor riding alongside over here. So this is one 1/4-inch aluminum piece that stretches across. And what's nice about this is the case is all precision manufactured at Microform Precision down in Sacramento. And they do such a good job. They have all CNC press brakes and stuff. So they nail their tolerances. And I know if I bolt these rails in on the side, they're going to be exactly the right length. There's enough slop in the screw holes for the carriages that you just a little bit of alignment, leave them loose until you're ready to tighten the whole thing down. So anyway, tighten those down, and then it carries this motor. It's just a single belt loop, so it moves on a single belt loop. And I've been doing this style of E-chain, which I like. There's another way to do it where it's attached here, and then it just goes across to here. But I like this. So you can print, what is it, 10 by, I think it's 10 by 10 by 12. And so very inexpensively you can enclose this. You'll have tons of heat on the inside if you want to enclose it with an acrylic door. Make your own top, or maybe we'll have some option to buy a top from us. But I like the base unit to be as cheap as possible, but it is going to go with the all-metal, the high temp, UBIS 13S high temp. So this is really for people that are really serious about using any material, any requirement for material like the heat bed, very robust, and it's pretty large. So it's a pretty large build volume, but the case is large. And it's a large case because there's only so much room. You have to add the room for the carriage on either side onto the build volume. So it ends up being a little bit wider than you'd like, but it's not that much waste inside. You could, we like to mount the filament. We'll have a little stand for the filament, so it's just right over the back, so there's no chance for it to fail due to, going through a long PTFE tube inside or whatever. I like the filament to just be really simple on the outside. Now you'll notice it does have a 3-point bed leveling system here. I haven't even leveled this bed yet. That was kind of a trade-off. The prosthetic bot guy wanted that. I left it on this one. I don't think it's really necessary. We could bolt that rigid to the frame and just live with however it's tilting. But when you have such a heavy carriage, and it's way off at the back, it's quite a way. It's probably at least 14 inches from the rail to the front. So there could be a little bit of sag based on the just the two carriages on one side and one on the other. There's 3 carriages. So it might sag just a little, but you could knock that out with this, these 3-point bed leveling systems. So you could accommodate once and for all to get that bed nice and flat, and then the auto leveling sequence will take care of anything else. So that's the Plus Pro. And you can envision a little LCD sitting down here. So there it is. Not printing, but we'll be printing tomorrow. So that's cool. I'll take that off the table. All right. Any questions on that? Okay, let's go through some questions on the Plus Pro. Can you see me? Not that you need to, but we're going to look at the Model 3 next. And then I got an email I got to send to. Let me send this email to you, Dave. This is regarding the files that I told you I would publish, I have the links right here. Links. So what I'm giving you is, daggone it, I couldn't find my Smalls Precision upgrade, but Dave's going to send the link to the the Smalls LE for the design files, the almost done Adopt-A-Bot V1.2. So I'm calling it 1.2 due to some internal confusion on 1.1. So I deleted 1.1 and I went to 1.2. So what this is on the Adopt-A-Bot is, it's right here. We've cleaned up some files on this just for aesthetics. We have a plastic extruder. We have the back. You know, this was kind of hokey, and I never explained it, but my intention was to glue this, but some people were like, dude, just go further, cut it here, have it bolt to the motor, so I've done that. But you can tell I'm not finished. But for you guys that are like dying for the files, I thought it'd be better for you to see the files, and you can print with them if you want, but you're going to be confused when I change them. So what else? I put right here, it's missing in this early 1.0. I put some little standoffs beside these screw holes so that when you tighten down that board, it stops on all four corners. So it's got standoffs. You don't have to print another little washer or anything. Saves a little bit of trouble there. What else did I do? So, I believe that's in this. I don't want to look right now. But this fan was kind of janky, so we added a screw in the last model. We added a screw to mount here to get that, and we added a screw mount that is not on this model. We added another screw mount over on this side, and I haven't even printed it yet. And what that does is keeps this nice and secure with two screws. So I think I'm going to change up that interface with the fan to simplify it. You won't need that. But anyway, so it's pretty cool. There's some changes that you can see on there. I'm just not quite done cleaning it up, but if you're anxious, you can check out that model and just stand by. I'll be updating it. And when I work on that, you'll probably see a bunch of parts disappear and reappear, disappear and reappear and change. But yeah, that's the 1.2 file. So, and there's already some community members publishing some mods. There's a guy that did a beautiful printed extruder along with a wire cover for the case, or the side of the case. And he actually did a ramps board instead of the printed board. And then he did a switch and I don't know why he put a fan on the back, but he put a cooling fan on the back, I guess for the motors. So there's already some people modifying that. Oh, I know what else is in that V1.2, which you'll have to be careful of because I haven't tested it yet. The Z-nut. Right now, this is a simple Z-nut. We're transitioning to a printable Z-nut, but the way I'm designing it right now, and you might be able to see it in the model, I put a really inexpensive, right off a McMaster car, what is it? 1/4-16 rod is what we're using. I know it's English, but there's like a cheap nut you can buy that just is going to fit right in there inside that mount. And there's actually another benefit that Acme nut part right now, it's this block that goes across. That block gets integrated to that other part. You got to print it upside down now. But that leaves some rigidity between the two sides. So we should get a little bit of better tolerance across in between these two rods. So I haven't finished the printable part for that. There was some stuff on Thingiverse, haven't integrated with it. And I expect there to be some play for adjustment. So if you got Z-wobble, this will take out that problem. Instead of trying to straighten the motors out, you'll straighten it out at the top to move the center line right above the motor. So that's gonna help there. So that'll be the next thing I finish on that. All right. So anyway, I've got the Adopt-A-Bot 1.2, the LE, and then the Smalls Z upgrade is also in the link. And I haven't yet found the Smalls Precision upgrade. Boom. So Dave, to-do item for you is those should go on the product pages eventually for each one of those. I'll post the Adopt-A-Bot one. But if those product pages aren't there, I don't know, we're going to figure out where to post these files. We probably need an aggregate place to get all of our files. But anyway, they'll be in the chat right now. They're already there. Look at him. Okay. So let's look at the Model 3. Oh, other Plus Pro questions. When can I buy it? Well, I have 5 cases right now. I'm going to probably keep one, so I'll put 4 up for sale very soon. But listen, it's been sitting in the wings for a while we get the prosthetic bot done, and it is done. It is at version, I think 7. Might be version 8, but he is now shipping, and you can check him out at Create O&P if you are a prosthetic maker. If you're a shop that does prosthetic limbs, you can go to him. If you don't have a need for a prosthetic printer with all of the decisions that he made and you'd like to get a printer that's almost that big from us, yeah, you'll be able to buy from me. So I'm hoping it'll be, within a couple weeks. They don't take that long to build, like maybe one guy a day, part of a day. Now that we have all the parts fabricated. Oh, that's not true. We don't have all the parts fabricated. We're making the top carriages, the stuff that you saw that were silver. We're making those in-house still. So we haven't really ramped up production. There may be a very limited number available, and the price point is going to be, I've already done the costing for the bot. It will be, it'll be under $3,000, I'll tell you that. So when you compare it to like a high-end, the big model of the MakerBot, the Taz flagship, you kind of, apples to apples is like this. So if you have a box that can be enclosed, that competes with other boxes that are or can be enclosed. So you kind of got to, the Taz is not enclosed. The Printrbot Plus is not enclosed. You get into a lot of cost when you wrap that thing in metal. So then you have to compare the printers that can print in any metal or any plastic with a high-temp hot end, which are none. Anyway, there are other solutions. You can hack your own E3D and get all that running with ramps or something. But so anyway, it's kind of unique in that way. So it'll be 3,000-ish. Just curious, is that a rigid or flexible? Is he talking about the filament? Oh, the Z motor on what? The Plus Pro. So that is a rigid, and it is in between 2 very large 15-millimeter linear rail carriages. And the motor at the top is a rigid mount, but it doesn't hang on that. It actually has a flanged roller bearing at the bottom that bears all the weight on a 4-start TR8, 4-start 8-millimeter Acme rod. So that's how that works on the prosthetic. Now on the Model 3, the only difference of what I mentioned, all the weight is bore on the bottom. We actually are using the open build anti-backlash TR8, it's a T8, anyway, Acme nut. You can dial in the tension on that so there's no backlash. Not that it's going to have any because it's a heavy bed. It's always going to go down. But the Model 3 is an even bigger bed, I'm about to show you, and it has a geared stepper, meaning 17 stepper on it. So. Was there another question? I saw several fly by there and it went to the ton. Okay. I know I'm going kind of long. All right, well, let's look at the Model 3. So while we had last week, or 2 weeks ago, I forget, while we had one of these showing, we've already revved the files, and now it's finished. And what we didn't realize was we're waiting tomorrow or maybe Monday. These Z-rails are coming in. So we kind of cheated, and it's a little too short right now. So you can see the Z-rails aren't long enough. It usually has this bar equal in the back, so there's quite a bit more. He's just got a screw in there on the Z right now, so it's just sitting there on gravity. So there's that. But anyway, so the idea is that this whole Z, I don't know if you can see that whole Z in the picture, but you see how it just bolts to the back rails? This extrusion is FazTech extrusion. You can get it on Amazon. And what we've done is we've designed the Faztech extrusion to a specific size because we wanted 2 feet of travel, which with the new rails we get, it'll be that travel. And those just bolt to these aluminum plates, 1/4 inch aluminum. We water jet them. And so 1/4 inch, 1/4 inch, 1/4 inch, and that hole with 4 bolts, and then you'd have to decouple the geared stepper. You can slide that whole Z carriage off. And then you can take the 4 bolts here, here, and here off of the carriages, and that will flat pack. So you've got the Z carriage in 2 parts that will be very flat, and then this top piece is what carries everything else. So everything else is just bolted to the frame with 8 bolts, 2, 4, 6, 8 bolts. And so it's a pretty neat design that it keeps things very, very simple. And you will be able to order it without the extrusion. There's a reason for that. It will be a kit. It'll be at first, it'll be a partially assembled kit. And we'll see what the demand is. There may not be anybody who wants one of these. But the reason I'm doing it as a kit is because I want people that do want to travel on an airline with a very large printer in tow. I mean, this is a very large printer to be taken on an airline. But if you can imagine this one plate, which does have, you know, the E-chain is here. You can take that E-chain off, but, you know, it's like this tall on the top stage because the hot end's down here. So it's that tall on the top stage. And then this is about, how tall is that? This is about the same height. And then the Z-rail is very skinny. So you can imagine that packing down very tight. And then I'll show you what, you can leave the camera there. So then this is the kit from Faztech. So we ordered this kit. We ordered 3 or 4 of these. And they do all of the way, and we can show you how to order this. We put the lengths on all the bars. We told them what hardware we wanted. And I think it was like $260, $220, $260. So the frame itself here, and I think this even includes the feet, which are actually pretty expensive and you could omit, but somewhere around $260 plus shipping, which don't order shipping like I ordered shipping. Jeez. So anyway, that you can order yourself, and it saves the most amount of money because the cost of the cost of a printer that is that big is really if you try to wrap it in metal, and you know, like we did with Plus Pro. It adds a lot of cost. So you'll be strung between, do I want even bigger build volume and I'll hack my own frame? And by the way, the files for that Model 3 is what we're calling it right now. That big one, I'll open source those files. You can make it yourself if you want, or you can order my kit, partial kit, and just get the extrusion from Faztech yourself. Because if it goes through my hands, I got to mark it up, and you don't want to pay that. So you could get it you could build that thing much cheaper than if I could I build it for you. Because you can tell it's not really a finished printer. It's one for you crazy makers, and I'll let you use parts from me, or you can build your own. I'll open source those plans, and you can order your own rails. I've already had somebody ask, well, I want a tall printer. He went like 6 feet tall. And I was like, well, I've saved you a lot of time if you want to take the files and cut them down to what you want on the XY and get those made yourself. And then you can order extrusion as long or as short as you want. So there's all these people building all these kind of extrusion bots. I really think we've got the simplest one you could possibly build. I've overdone it on that 1/4 inch plate, but it's really just fun. And we had a prosthetic customer, Create OMP, that needs to go to Nepal with that thing, so it's going to flat pack and go on the plane. So there it is, done. Any questions? What's the max build plate temp on the Plus Pro? Let me tell you, that 200-watt AC heat bed will heat up so much faster than our PCB heat bed, which might take 10, 15 minutes. Easy. This will heat up much faster and go way above 100. I think it actually tops out. There was some spec. Do you remember? No? It actually is designed to if you just leave it wide open and just plug it in, it'll go to, I forget what it is, like 130 or 150 or something, I forget. But just look on Kinovo on Amazon.com and you check it out. They have the specs there. So that is the 8x8 heat bed 200 watt AC. So check it out. What else we got? Anything else? All right, guys, I know it's a lot of stuff. It's 5:26. I've got an hour. That's all too common. But there it is. You got to see some cool stuff. So the Adopt-A-Bot. I do have a quick update on that. So I don't have them in here. So I'll keep this short. So I said this last week. So we've made the wiring kit include soldering. And we've already, my wife, God bless her, Margie, she has already put together 25 kits for that. And Carl has agreed to donate some ceramic hot ends for the next round, at least 50 of the next round. And by the way, these are all upcycled things. Specifically, the ceramic, those were never sold as new and never used. They're just parts. When we discontinued it, he had a bunch left. And so he goes, I can take those spare parts and put them together and donate them. So that's awesome. So what that tells me is the first 25 and hopefully the first 50, I'm going to sell right out of my shop here and simplify, because I was just so stressed out with how are we going to get these wires to them? They're going to put them together and solder them and all that. And I thought, wait a minute, everybody can solder. So my wife just finished off all the cutting, the crimping, and the housing. So these packs are all identical. And I did a video today. Maybe we can get that video up tomorrow, Dave. I did a video today of me going through the pack just as you will receive it. And I show, these motor wires are done for you, so enjoy. This little 3-inch end stop is done for you, enjoy. But here's the stuff you're going to have to solder, and here's how you do it. And I even put heat shrink in there for you. So I've done all of the wiring and showed you how to do it. So it will require, if you buy one of these Adopt-A-Bot in this next phase, which I'm going to try to get up for sale within the week, by maybe next week's show, I'll have 25 ready. They are $99, and so what that is going to do, thanks to Carl's generous donation, it gives me enough room to take stuff off my shelf, not refurb anything else, just take stuff off the shelf, and also ship it in the U.S., and I might not argue if you were in Canada. But understand, I'm doing it, well, I said, we have to decide yet how we're going to handle that shipping, don't we, Dave? I might knock it down to 85, and then they have to pay for shipping. You said that it ships was somewhere around $15, $16. But if somebody orders it abroad, we could say, well, order it from wherever you want. If it was $85, people in the U.S. get it for $100-ish. Yeah. And then if they want to ship to Canada, everybody's very critical of my shipping rates. But we just put it on whatever, UPS or anyway. So that would be one way to go. But I know that I'm going to sell the first 50 right out of the gates here, and we'll see how it goes. Hopefully we can turn more and more and more of the process over to the community, like nuts and bolts and so on. But I don't want this to lag so much due to me being the bottleneck for organization. I don't want it to lag and lose the fire. So I need to get these things for sale, and we need to get the builders building and everything. So there will be a product that you will be able to buy intended for one purpose. This will be somebody that is ready to print their own parts, no printed parts. They will build it themselves. And by the way, the model is updated with screws now. So if you're wondering what screws go where, it's in the model. And the V1.2 may have a slight change on some of those, depending on my design changes. But you'll be able to order this product, print, build it, and then we want you to handle the delivery to a school and support them. So that's what this is for. Now, will some slide through the cracks? Probably, but it's not going to be of great value to you because it ain't going to be easy to assemble with all the soldering and the printing and the building. So, and there's no support from, we're not going to say, oh, you're having trouble? Let me hold your hand. No, you're going to be on your own because you guys that are buying these are awesome folks with lots of skills that want to donate to a local school. So that's what the intention is. So I'm just going to release it and let her fly. So anyway, I realized that I've been like, oh, I want all these people to help, refurb stuff, but I really decided that was a waste of time, Brooke. What are you thinking? We want the people to get in the classroom with the printer. That's all that matters, is that you get into the classroom with a printer. So I'm just going to stop worrying about who's going to cut the wires, and I'm going to cut the wires. I'm going to put the kits together to get off to a start, and then we will move all of this based on the popularity of the whole thing. We'll move this off to the community. Now, one thing that I thought was funny was a guy in the UK said, well, I want to start a thing in the UK. So I promised him 25, I'm going to send him a big old box of stuff, and he's going to get 25 of these kits. I'm going to just pay for the shipping to get it over there and donate it. And then people in the UK would be able to participate in this program based on him and a couple others that have stepped up to do it in the UK. So I'm open to other countries doing this, because the problem with us doing it here and saying US only, well, they're jealous, they want it too, and all kids are awesome, so why don't we try to make this happen? But they will have to lean on their local sourcing more. So I looked on Amazon, and there's motors for sale on Amazon as cheap as I can buy them and ship them. So we'll outsource as much of the stuff that we send to another country from like Amazon.com or something like that. So that's pretty cool. That's going to happen too. So anyway, that's the Adopt-A-Bot. I think we got it. What else?
No, not really any questions. There's one here that says, instead of the rails on the CD, would you replace them with extrusion in the chassis?
Yeah.
I think he's referring to the
Yeah, right. And I've done that on tests for other bots, but I decided that it's kind of a waste of time for me to do that, because I wouldn't sell a printer to a commercial, like Open Builds has these printers that run on V-bearings and extrusion and stuff, and it's great for the maker because they work pretty good, but they do require maintenance. They get loose, the Delrin wears. The Crawlbot has Delrin like that, but it's, it's really wide, and it has to carry just a little bit of weight, a router, which arguably is pretty heavy. But when you're doing CNC, you're up for maintenance. Well, people that want a big printer don't necessarily, in a commercial setting, wouldn't necessarily want to, well, this wheel wore out. Where do I get a custom V-bearing Delrin roller wheel in Nepal? So it's not likely that the bars in the carriages are going to wear out anytime soon. You keep it lubed. So that's why I've chosen to go with those. But yeah, you could do that. You could just replace that Z-stage with something of your own making. Good luck with that, but I'm not going to do it just for certain reasons. I don't even know if that thing will sell, so I don't want to waste too much more time on it. All right, thanks for staying longer than an hour, guys. 5:34. You have a great week. I do hang out on Twitter and Google+, so look for @Printrbot if you've got questions or just want to be part of the community. Join us there. So have a good week. Talk to you soon.